Okay, the problem now, the Taylor series has been generated not at 0, the chlorine, but at 3. All right? So what you have to do is you have to write down the derivatives. And they can be difficult to do, but for the geometric series, they're really not bad to do. I would recommend writing this down, though, as a geometric. It's 1 minus x to the minus 1 power. And as you start writing the derivatives down, you start to realize they're fairly simple to put down. What are you going to get over here? It's going to be 1 minus x to the minus 2. Now, if you do the chain rule, of course, you realize that the negative terms cancel off, and so forth and so on. Let me put this one over here for you. What's that going to be? Well, it's going to be 2, 1 minus x to the minus 3. The triple prime, that's going to be 2 times 3, which is 6. 1 minus x to the minus 4. And I'm starting to realize, there's definitely a pattern over here. And I'll write it down for you. So I'm going to write down Fn. And I see the 1 minus x. Let's just carefully look at it. A 3 gives you 4, 2 gives you 3, 1 gives you 2, none gives you 1. So I'm going to write down, it looks like minus n minus 1. We'll clean this up in a moment, by the way. Now I'm looking at the number in front, and it looks like just a factorial of the level of the derivative. For example, this over here, whoops, sorry about that. Coefficient of 1, that's 0 factorial, 2 factorial, 3 factorial. By the way, this is 0 factorial there. So I'm going to put down n factorial. I'm going to rewrite it a little bit differently. Write it as n factorial divided by 1 minus x to the n plus 1. All right? What do I got to do now? I got to do an evaluation. And the evaluations, I want to point out that they shouldn't be too difficult to do, but they might be annoying to do. That's possible. A is equal to 3. So A equals 3. So what do? I start to evaluate each one at 3. So let's do the first one. What do you get there? If you put a 3 there, you get 1 over 1 minus 3, which is going to be 1 over minus 2, which is minus 1/2. Let's just do the next one. Again, a simple pattern to it. What's that going to be? Well, that's going to be 1 over, again, I'm using 3, so it's going to be 1/4 now. I wrote it down as 2 squared, by the way, for a reason. Right? What's the next one going to be? Well, I'm looking at it, it's going to be 2 over 2 cubed, but they alternate back and forth, plus or minus. And then 6 over 2 factorial, yada, yada, yada. I definitely see a pattern to this as well, by the way. And the pattern is really over here. All right? Let me write that down for you. So Fn, whoops, didn't mean to put that down. Simple pattern. That's going to be n. I did it again. Oh, no, I'm sorry, it's 2. What am I saying? Not 2, it's 3. What am I saying again? I got 2 in my brain. That's going to be n factorial. And then what do you get over there? You get minus 2 to the n plus 1. All right, that looks strange, doesn't it? So I'm going to write it a little bit differently. And I'm going to write it as, this is n2. Sorry about that. And what do you get there? You get n factorial, you get minus 1 to the n plus 1, and then you get 2 to the n plus 1 here. This explains the alternating part now. Fn, 3, is going to be minus 1, n plus 1, n factorial, over 2 to the n plus 1. That's what's written over here. And then what I do, I just write down a Taylor polynomial. That's all you have to do. So, how do you do that? It's fairly easy to write down. I got a nice pattern to it, very predictable. And f of x is going to be, let's just be careful about this. And it's going to be f evaluated at a, right? And then over, let's see, 0 factorial. And then it's going to be x minus a to the 0. I'm just going to write a few down. It's going to be f prime at a, x minus a to the first power over 1 factorial. I think you get the idea that I could do this with that pattern over and over again. So I'm going to write this f of x down. What's that going to be? It's going to be 1 over 1 minus x equals, Well, I'm going to do what I said I was going to do is this thing over here. And what's that going to be? Well, let's write that down. And I got to be careful about this. And it's going to be, let's see, minus 1/2. That's what f of a is. I'm not going to write the 0 factorial down. Next minus 8, that's just 0. Let me put the next one down. So the next one's going to be plus. That's going to be 1 over 2 squared. And then I got this, let's see, 1 factorial on bottom, right? And then I got x minus, what's the a again? The a was 3, right? Let's put the next one down. That's 1 factorial. I want to get a pattern to this, by the way. And that's going to be, let's take a look. I'm seeing that over there, and that's going to be, oops, stop, plus it's minus, right? It's going to be what? I get 2. I get 2 cubed. And then I'm going to get x minus 3 squared. Plus, now before I go any further, it's important I start to realize that this is really what's giving me the pattern over here. All right? So I want to mimic it. I want to mimic it. All right? And what do I notice about this over here is that, basically, I'm seeing something over here, and I'm going to mimic what I see. Let me see if I wrote it down right. And I'm going to say, let's take a look at that. So this would be, let's see, 0 factorial, and I could put a 0 factorial over here just to mimic what I would normally see there. All right? And then I'm going to put a 1 factorial here, and then I'm going to say that's really 2 factorial over 2 factorial. So I'm starting to see this thing playing out. All right? So what I want to do is I'm going to write the summation notation down. That's not 10 factorial. It's 1 times 0 factorial. Let's write this down. And I'm going to say n equals 0 to infinity. We'll get the same thing we're expecting, by the way. I'm expecting to see x minus 3 to the nth power. And again, 0, 1, 2, 3, so forth and so on. What else am I expecting to see? Well, I noticed the factorials cancel off, all right? And now I'm looking at the powers of 2. So what's that going to be? Well, let's be careful about that. That's going to be 2 to the n plus 1. Again, I'm seeing 1 here, 2, 3. And then what else do I see? I see this alternating pattern, which is minus 1 to the n plus 1. Let me just go back over here and emphasize we should be seeing this in the pattern right over here. Are we seeing that? Let's take a look at that. We are. The factorials canceled off. I do see the 2 n plus 1 minus 1, and I do see the x minus 3 to the nth power. All right, I'm going to commit to this over here. Before I do that, though, I also want to claim that it's probably a good idea to write down the interval and radius of convergence over here. So looking at it, it's certainly, looking back at the original, I know that the interval goes from minus 1 to 1. I hope you realize that. So really what I'm looking at is, let's do the ratio test. Let's put that down, ratio test. Let's see, limit, n goes to infinity. Let's write this down. And the minus 1s are going to cancel off. So what am I left off with? X minus 3 to the n plus 1 over 2, n plus 2. 2 to the n plus 1 over x minus 3 to the n. What do I get over there? Limit, n goes to infinity. The absolute value of, let's see, that would be x minus 3 now. All right? And then what happens with the 2's? I get a 2 on the bottom. What's that limit going to be? Well, it doesn't involve n, so it's x minus 3 over 2. Should be less than 1. So x minus 3, you have to divide that 2, which means x minus 3 is between 2 and minus 2. I'm going to add 3 to all sides. I get 1, and I get x, and I get 5. So the other thing I want to point out is that maybe testing the endpoints too. And certainly I didn't do any shenanigans. I'm not expecting to get the endpoints, but let's just go through that. If I tried 1, what would you get? You'd get this over here. let's see, if I tried 1, I get minus 1. That would be, let's write this down. I'll write it on the side. Minus 1 to the n plus 1. I'm plugging in x equals 1 now. And you're going to get minus 2 to the n. Over here you get 2 to the n plus 1. Well, I get minus 1, n plus 1. I get minus 1 to the n. And then what do I get over there? I get 2 to the n. And at the bottom I get 2 to the n plus 1. What happens over there? Let's see, you would just get 2. And what do you get on top? You get minus 1 to the 2n plus 1. And what do I know about that? That test version just fails in that one, so I'm not include that. Let's try the 5 now. You get minus 1, n plus 1. That would be 2 to the n. And we're checking x equals 5 now. And then it's n plus 1. So you get minus 1 to the n plus 1. And then you get 2 to the first power. Again, test version, that fails too. So this is going to be our interval. Let me write this down, I. And that I is going to be from 1 to 5. And the radius of that, looking at it, what is it going to be? Well, the length that's 4, so the radius is 2. Let's just look at the key, by the way. And I want to make sure this is written down for you. And is this written down? Let's take a look. Be careful about that. They start at 0, go to infinity. Minus 1, n plus 1. Yeah, looks good. And did I get the radius? I did. And did I get the interval? I did. We're good to go.